Good morning, class. I hope you guys are well. So today we'll talk about how to solve quadratic equations by factoring or by factorization. Now we have already looked at factorizing quadratic equations, so you guys are already pros at that, and we're just going to extend it one little step further and see how we can solve quadratic equations by factoring. So I'll tell you what I mean in a second. But before we even get there, do you guys remember these puzzles and do you remember how to solve them? So go ahead and pause the video and solve this puzzle and submit your answers as part of your work for today's work. So yeah, solve the puzzle, submit your work. Now, yesterday and on Tuesday, we looked at graphing quadratic equations. And every time we graphed quadratic equations, we got these points here that we called X-intercepts, right? X-intercepts. X-intercept, this was the other X-intercept. And I hope you remember that we discovered that a quadratic graph can either have two X-intercepts or it can have none or zero X-intercepts, right? These are the possibilities for a quadratic equation. It either has two or no X-intercepts. A quadratic equation also has a y-intercept, which is that point down there, and it also has a lowest point or minimum point or vertex or turning point. So we saw all these things yesterday. What I want us to focus on today are these points here called the x-intercepts. So since we know that a quadratic equation can either have two x-intercepts or no x-intercepts, then we're always going to be trying to figure out what are the x-intercepts of a quadratic equation, and do we always have to draw a graph to find those x-intercepts? Now, in practical applications of this, when we model situations using quadratic equations, when we draw x-intercepts of those quadratic equations, I hope you guys remember that this line that I'm drawing an arrow on is the x-axis, right? That's the x-axis. And the x-axis is also the line y is equal to 0, right? That's the same thing, the line y is equal to 0. Because this would be y is equal to maybe 1, maybe 2, 3, like that. Y goes upwards and y goes downwards on the opposite side of the x-axis. So that means this is the line when y is equal to 0. So what we are basically doing when finding x-intercepts is we are equating this quadratic equation, that quadratic equation x squared minus x minus 20, we are equating it to 0, right? When we equate the quadratic equation to 0 and we try to solve, what we get from that solving is what is called the x-intercepts. Now these x-intercepts have so many names. X-intercepts, or they can be called solutions to a quadratic equation, or they can be called the roots of a quadratic equation. You will see this word a lot in 9th grade and 10th grade. They can be called the zeros of the quadratic equation. You will see this word in 11th grade. But for 8th grade at this stage, we will use these words to mean solving quadratic equations. So every time we solve a quadratic equation, we are looking for the solutions to that quadratic equation. And you guys know that the solutions are the same thing as the x-intercepts of the quadratic equation. Now, obviously, you can always just graph the quadratic equation to get those solutions. And there are so many tools that you can use to graph. For example, if you go online and you just go to desmos.com/calculator, if you just Google this, desmos.com, the first link that comes up and you click it and you type in this equation, it will give you the the graph. It will give you this exact graph because that's where I got it from. We'll give you this graph and you'll be able to see the x-intercepts easily. But the point of this lesson is to try to see how we can use analytical methods to find those x-intercepts, right? We don't always have to draw a graph. We can use analytical methods to find those x-intercepts, and you're going to be tested on this a lot. So when we want to do this, when we want to solve for this quadratic equation, what we do, first of all, we need to solve the puzzle, obviously. So we have a 1 here, the 1 goes, make this bigger, the 1 goes here, and the negative 20 goes here, and we want our result to be equal to negative x. So you guys are pros at this, you remember this so well. Factors of 1x squared are just 1x and 1x. Factors of 20 that I can combine to get a negative, I'm going to use positive 4 and negative 5, because positive 4 times negative 5 give me negative 20. And then here I'll have 4x, and here I'll have negative 5x. So my new expression, my factors, I hope you guys can see this. My factors are, I got the diagonal and diagonal. So my factors are x plus 4 and x minus 5. But remember, this is equal to 0. If I want to find the x-intercepts or the solutions, it has to be equal to 0. And why is it equal to 0? Because the line y is equal to 0 is where I have x-intercepts, right? So it has to be equal to 0. Now I have two brackets that are equal to 0. How do I get from there to find actual x-intercepts? Let's see. So in mathematics, and not just mathematics, I think general life, if the product of two things, if I have p times q and their product is equal to 0, right? Just look at this critically. If the product of two numbers is equal to 0, then that surely means that one of them must be equal to 0. Because if you think about it, if I multiply 1 times 0, I will get 0. I don't know what these numbers are, right? But I know that if their product is equal to 0, then one of them must be equal to 0. If it could have been maybe 0 and the other number was 4. All I know that since their product is 0, one of those numbers must equal to 0. Now since I don't know what p and q are, but I know that their product is 0, then it's logical to conclude that either p is equal to 0 or q is equal to 0, right? Since I don't know which one is equal to 0, I can conclude that either one of them could be the 0. So that's the idea that I will use to solve this expression, because I have x plus 4 open brackets x minus 5 is equal to 0. Since I don't know which one of them is 0, right? This is a product and it's equal to 0. I don't know which one is 0. I will say either x plus 4 is equal to 0, right? And if x plus 4 is equal to 0, then I can subtract 4 from both sides and I'll get x is equal to negative 4, right? That's one of the options. The other option is or x minus 5 is equal to 0, and if x minus 5 is equal to 0, I add 5 both sides and I'll get x is equal to 5. So these are my two x-intercepts for this quadratic equation, right? And remember, x-intercept is the same as solution, is the same as roots, is the same as zeros. And I hope you can see that I am getting the x-intercepts, the same x-intercepts as this graph showed me. So the graph is not the only way that you can find x-intercepts. You can also find x-intercepts by solving, which is what we have just done here to find these x-intercepts. Alright, let's look at another example. Now, one key idea when you're solving for this and trying to find the x-intercepts is that you need to make sure that your equation is equal 0. So this equation that I have here is not equal 0. So I need to first make sure it's equal to 0. In order to do that, this 49 needs to move away from that side and come this side, right? But before that 49 moves, I also need to first multiply out what I have on the left. So I'm going to multiply out this, and I'll multiply out that. So that will give me 3x times 3x is 9x squared, and 3x times 14x is some big number that I don't know. 3 times 14, I really should know this. 3 times 14. I knew it. I was just checking to see if you guys knew it too. So that's 42x, and now I'm going to bring the 49 this side, right? And since it's negative, when it crosses over, it will become positive. Now I have it equal to 0. Okay? So since I have it equal to 0, I now have a quadratic equation that is equal to 0. So that means I'm trying to solve for x, or I'm trying to find the x-intercepts. So I will start my process of solving. So this is 9x squared, this is 49, and I want to figure out how to make this equal to 42. So 9x squared, I can use 3 and 3. I can use 3x and 3x. And 49, I can use 7 and 7. So let's see, 3x times 7 is 21x, and 3x times 7 is 21x. So 21x plus 21x is equal to 42. So that means that my factors are those numbers and that number. So I have 3x plus 7, close brackets, 3x plus 7 is equal to 0. Now remember, if the product of two numbers is equal to 0, then either one of those can be equal to 0. So I have either 3x plus 7 is equal to 0, then I'll subtract 7 both sides, and I'll have 3x is equal to negative 7. And if I want to find x, I will divide both sides by 3 and end up with my x as equal to negative 7 over 3. Okay, that's one of the options. The other option is or 3x plus 7 is equal to 0. Now I hope you can see that this is the same thing that I've been doing. So 3x plus 7 is equal to 0. I'll have the same answer as I had previously, negative 7 out of 3. So this is the same x-intercept that this is the same x-intercept that I had as here. These are the same exact numbers. So that tells you that it's possible for a quadratic equation to have one x-intercept, right? So there was a question yesterday on your quiz which confused some of you. The question was asking which of the following are true for a quadratic equation, for the number of intercepts of a quadratic equation, and the options were 1, 2, or none, right? So I showed you earlier at the beginning that it's, I don't know if I showed you today. No. You guys saw yesterday that it's possible for, a quadratic equation, yeah, I showed you today, has two solutions, right? It can have two solutions, it can have no solutions, and now we have seen that a quadratic equation can also have one solution or one x-intercept. Now in further math you'll find that this is called a repeated solution, but for now this was the answer to your question from yesterday. So yeah, that's it. I'm going to post your homework or some practice questions for you on Google Classroom. I hope you enjoy them. Bye.